Picture this. You're an astronaut, strapped into your seat, ready for liftoff. The countdown begins. 3, 2, 1, ignition. Suddenly, you're thrust back into your seat with incredible force. This is where inertia dampeners come in. They're not just sci-fi mumbo-jumbo. They're a real technology that could revolutionize space travel. But how do these miraculous devices work? It's all about manipulating inertia. Inertia dampeners essentially trick physics by creating a field that counteracts the effects of inertia. This field allows the spacecraft to accelerate or decelerate rapidly without the occupants feeling the full force of the change. The possibilities are as vast as space itself. Now, let's dive into the nitty-gritty of how inertia dampeners work. It's not magic, folks, it's science.
The key to inertia dampening lies in the manipulation of mass and gravity. Sounds impossible, right? Well, hang on to your hats because we're about to get weird. One proposed method for inertia dampening involves the use of negative mass. Yes, you heard that right, negative mass. It's a theoretical concept that behaves opposite to normal matter. By creating a field of negative mass around a spacecraft, we could potentially cancel out the effects of inertia.
Another approach involves artificial gravity. By creating a gravitational field that opposes the direction of acceleration, we could counteract the forces acting on the spacecraft and its occupants.
The materials needed for inertia dampeners are equally mind-bending. We're talking about exotic matter with properties that defy our current understanding of physics. These materials exist only in theory or in tiny quantities in labs. But as our technology advances, who knows what we'll be capable of?
Now, let's shift gears and talk about something even more mind-blowing: warp drive. If inertia dampeners are the seatbelts of space travel, warp drive is the engine. It's the holy grail of space exploration. Why? Because it could allow us to travel faster than light.
Here's the problem with space travel. Space is big. Really, really big. Even at the speed of light, it would take years to reach the nearest star system. But warp drive offers a loophole. Instead of moving through space, warp drive moves space itself.
The concept of warp drive is based on the idea that space itself can expand and contract. By compressing space in front of a spacecraft and expanding it behind, we could create a warp bubble that moves faster than light.
Inside this warp bubble, the spacecraft itself isn't moving faster than light relative to its local space. It's the bubble that's moving, carrying the spacecraft along with it. This clever trick allows us to sidestep the cosmic speed limit without actually breaking the laws of physics.
Section 4. Alcubierre Drive. Riding the Wave of Space-Time. The most famous concept for a warp drive is the Alcubierre Drive, named after physicist Miguel Alcubierre.
In 1994, Alcubierre proposed a solution to Einstein's field equations that would allow faster-than-light travel.
The Alcubierre drive works by creating a bubble of warped space around a spacecraft. In front of the ship, space is compressed. Behind it, space is expanded. This creates a wave in the fabric of space-time that carries the ship along. The ship itself remains stationary relative to the space inside the bubble.
One of the coolest things about the Alcubierre drive is that it solves many of the problems associated with near light speed travel.
But here's the catch. The Alcubierre drive requires some pretty exotic materials to work. Creating and harnessing this negative energy is well beyond our current technological capabilities.
Section 5. Combining Technologies, a New Era of Space Travel. Now, let's put it all together. Imagine a spacecraft equipped with both inertia dampeners and a warp drive. This isn't just a faster, safer ship, it's a revolution in space travel.
It's the difference between a horse-drawn carriage and a supersonic jet.
With inertia dampeners, we could accelerate and decelerate rapidly without turning the crew into human pancakes. This would allow for more efficient travel within our solar system. We could reach Mars in days instead of months.
Add a warp drive to the mix, and suddenly the stars are within our reach. We could visit Alpha Centauri, our nearest stellar neighbor, in weeks rather than millennia.
But the benefits wouldn't be limited to space exploration. The technologies developed for inertia dampeners and warp drives could have profound impacts here on Earth. The energy manipulation techniques required for warp drives could revolutionize our power generation and storage capabilities. Section 6. The future of interstellar exploration. As we stand on the brink of this new era of space travel, it's natural to wonder, what's next? Where do we go from here? The answer is simple: everywhere. With inertia dampeners and warp drives, the entire universe becomes accessible. We could become a truly spacefaring civilization spreading out among the stars.
But let's not get ahead of ourselves. These technologies, as promising as they are still in their infancy. Inertia dampeners are theoretically possible, but far beyond our current engineering capabilities. Warp drives require exotic matter and energy that we don't know how to create or control.
That doesn't mean we should give up, far from it. The history of science is full of impossible things that became reality.
The key is to keep pushing the boundaries of what's possible. We need to invest in basic research, in the kind of blue sky thinking that leads to breakthrough discoveries. Because one day, perhaps sooner than we think, we might just find ourselves surfing the waves of space-time, exploring the wonders of the cosmos. The stars are calling. It's up to us to answer.